Carbohydrates are the most debated macronutrient in the world. Some say avoid them completely, while others rely on them to power through their days. But what does the actual science say? Welcome back to Food Science Made Simple. Today, we are diving deep into carbohydrates. We are going to cover exactly what they are, the different types, what happens when you eat too much or too little, and most importantly, how much you actually need based on the latest ICMR and NIN guidelines. Let's get into it. Let's start with the absolute basics. A carbohydrate, chemically speaking, is an organic compound made up of carbon, hydrogen, and oxygen, often abbreviated as CHO. They are primarily synthesized by plants through photosynthesis. Out of the three major macronutrients, carbs, proteins, and fats, carbohydrates are the body's preferred and most efficient source of energy. Every gram of carbohydrate provides about 4 kilocalories of energy. When you consume carbs, your digestive system breaks them down into glucose. This glucose is absorbed into your bloodstream and acts as the primary fuel for your central nervous system, your brain, and your working muscles. Without it, your body has to work much harder to synthesize energy from other, less efficient sources. Not all carbohydrates are created equal. In food science, we classify them based on their chemical structure, which dictates how fast our bodies can digest them. First, we have simple carbohydrates. These have a very basic chemical structure, meaning they are digested and absorbed rapidly, giving you a quick spike in energy. They are divided into monosaccharides, which are the simplest single sugar units like glucose, fructose found in fruits, and galactose, and disaccharides, which are two sugar units linked together. Examples include sucrose, which is standard table sugar, and lactose, the natural sugar found in milk. Next, we have complex carbohydrates, or polysaccharides. These are long, intricate chains of sugar molecules. Because of their complex structure, they take much longer to digest, providing a slow, sustained release of energy. This includes starches, found in abundance in cereals like wheat and rice, roots like potatoes, and legumes. We also have glycogen, the storage form of carbohydrates in animals and humans, stored in our liver and muscles. Finally, there is dietary fiber, found in whole grains, vegetables, and fruits. Humans lack the enzymes to digest fiber, but it is crucial for gut health and regulating blood sugar. So, what happens when we disrupt the balance? Let's look at excessive intake first. When you consume more carbohydrates than your body needs for immediate energy or glycogen storage, the excess is converted into fat through a process called lipogenesis. Over time, consistently high intake, especially of simple, refined sugars, can lead to obesity, insulin resistance, and an increased risk of type 2 diabetes. On the flip side, what happens with a severely decreased intake? If you don't eat enough carbs, your blood sugar drops, leading to hypoglycemia. You'll experience fatigue, dizziness, and poor mental focus. To survive, your body starts breaking down muscle protein for glucose and shifts to burning fat, producing byproducts called ketones. While some people use nutritional ketosis intentionally, a severe lack of carbohydrates over time can compromise your energy levels and muscle mass. This brings us to the most important question: how much carbohydrate do you actually need? For the Indian population, we look to the dietary guidelines provided by the ICMR and NIN. The ICMR and NIN recommends that carbohydrates should provide about 50% to 60% of your total daily energy intake. Furthermore, they recommend a minimum intake of at least 130 grams per day for adults and children to ensure the brain gets enough glucose to function properly. But your specific needs depend heavily on your age and your workload. Sedentary workers, or people with desk jobs, need the baseline amount. The focus should be on complex carbs and fiber to avoid unwanted weight gain. For moderate workers, if you are on your feet most of the day or exercise regularly, your carbohydrate needs increase to replenish the glycogen used in your muscles. Heavy workers, like manual laborers or high-performance athletes, have significantly higher carbohydrate requirements. They need large amounts of complex, energy-dense starches to sustain continuous physical exertion without extreme fatigue. Growing children and pregnant women also have specialized requirements to support rapid tissue growth and fetal development, meaning complex carbs are absolutely essential. To wrap things up, carbohydrates are not the enemy. They are a vital macronutrient that literally keeps the lights on in your brain and the engine running in your muscles. The key is choosing the right types of carbs and matching your intake to your daily physical workload. But carbohydrates are just one piece of the nutritional puzzle. While carbs provide the energy, there is another macronutrient that actually builds and repairs the very muscles using that energy. In our next video, we are going to dive into the building blocks of life, protein. We'll cover amino acids, biological value, and how much you really need. You won't want to miss it, so make sure you hit the subscribe button. Leave a like if you learned something new today, and I'll see you in the next one.